So this is another question on application of integration by parts. And when you're solving such kind of problems, you have to be very careful on what you pick as your U and what you pick as your dV. Because in some question, there's just one accurate U value or U function, and then one accurate value for dV. So you highly have to be very, very careful. So let's demonstrate how we're supposed to solve this. So we have to evaluate the integral of x cubed ln of x dx. So remember, integration by parts formula is integral of u dv is given by uv minus integral of v du. So the correct choice of u and dv is what will help you to break the problem into solvable form. In this case, the correct choice of u is ln of x, and then this x cubed dx will form the dv. So say let u to be ln of x, and so dv is the remaining part, x cubed dx. Remember, what guides on what becomes u and what you pick as dv. In most cases, when you pick u, then you have to differentiate that function, and what you pick as dv, you have to integrate that part. So you see x cubed and ln of x, it is easier to integrate x power 3 than to integrate ln of x. So then x cubed becomes, x cubed dx becomes the dv part. And also when you compare in terms, so once, remember the integration problem is really what is a little bit more involving than a differentiation problem. So once we know that we can't really get the integral of ln easily as compared to x power 3, then picking x power 3 to be dv is the best choice. So that does not mean that now we can't get the value of the integral of ln of x, but I'm just saying that if you combine in terms of the amount of energy you have to spend to integrate ln of x and x power 3 is much easier. So the u will be given by 1 over x dx, and then v will be given by x power 4 over 4. So therefore, this means integral of x power 3 ln of x dx will be given by uv, multiply this by this one, we have x power 4 over 4 ln of x, and then minus v du. So we'll have integral x power 4 over 4 multiplied by du, which is 1 over x, and then dx. Now, simplifying this, you say x cancels 1, so remain this part to be 3. Then I can factor out a quarter. So I'll have this to be x power 4 over 4 ln of x minus 1 over 4 integral of x power 3 dx. And the integral of x power 3 is not a very complicated function to evaluate. So next step, we'll get x power 4 over 4 ln of x minus a quarter. Integral of this is x power 4 over 4. So then at this point, I add constant of integration c. I remember this being an indefinite integral, you must always have the constant of integration in your last step. If you don't include that constant of integration, then you get it wrong. You don't score the full marks for such a problem. So this will be the same as x power 4 over 4. Actually, I can factor it out and say write this one as ln of x minus 1 over 4 and then plus c. That's one way you can write the solution. Or we can write from this one, we know you have x power 4 over 4 ln of x minus x power 4 over 16 plus c. So then I can factor out x power 4 over 16. And then so I need to multiply this one by 4 ln of x and then minus 1 plus c. All these are just different versions of writing the same thing. So whether you write this, you write this, you write this, or this one, all of them are okay. Unless the question pins you down on which form you have to leave your answer in, all those different versions are the solution to that particular problem. Thank you.